Hello my dear students, I warmly welcome you to CR Digital Classes. So now in this lecture we are going to discussing one of the very important problem repeated so many times, especially essay type of questions. Okay, so problem based on the right circular cylinder. Very important problem and very easy problem. First of all, observe the problem. Find the equation of the right circular cylinder whose guiding curve is x square plus y square plus z square is equal to 9 and the plane equation x minus y plus z is equal to 3. Okay, with the help of given guiding curve we have to find the equation of the right circular cylinder. Okay, so you know very well what is the process to find the equation of the right circular cylinder. First of all, observe the diagram on screen. You can see the diagram. Okay, so here we have guiding curve. This is the guiding curve, x square plus y square plus z square equal to 9 and x minus y plus z is equal to 3. First of all, I am writing a given guiding curve. Okay, so given guiding curve, x square plus y square, x square plus y square plus z square is equal to 9. Okay, this is exactly a sphere equation. Okay, having a radius is equal to 3 and a center is equal to 0 0 0, you know very well. And given plane equation, what is the given plane equation? X minus y plus z is equal to 3. Take it as equation number 1 and take it as equation number 2. Okay, so now after taking the guiding curve, now observe, for this is a sphere equation clearly. Okay, for this sphere equation here I am taking the center of the sphere, this point ma. Okay, this is the center of the sphere, that is I am taking O, origin. Why? Because for this sphere x square plus y square plus z square equal to 9, center is always we can take a 0 0 0. And what we can take radius of the sphere. What is the radius of the sphere? From this value we can see radius. This is the radius of the sphere. Okay, from here to here, this is the radius of the sphere. That radius I am writing small r. Small r is equal to 3. Small r is equal to 3. Small r is equal to 3 is the radius of the sphere. And this is the plane. Okay, whatever you are seeing, one more circle. Okay, that is called given plane x minus y plus z is equal to 3. Okay, so here I am writing everything ma. So this is the sphere x square plus y square plus z square is equal to 9, and here you have that plane equation x minus y plus z is equal to 3. Now from the center of the sphere, that radius is the given sphere, and we know very well radius of the right circular cylinder. Radius of the right circular cylinder is equal to radius of the guiding curve. So guiding curve, or we can call it as circle. Okay, so guiding circle. So now first of all we have to find the radius of the right circular cylinder. So to find the radius of the right circular cylinder, we have, what is the formula actually? So that is, we can write, that is capital R is equal to under root of small r square minus p square. Small r square minus p square. So this is the radius. In unit 1 spheres also, whenever you have a guiding curve as a circle, okay, combination sphere equation with plane, that is called circle. Okay, radius of that circle is, we derived from this equation only. Capital R is equal to under root of r square minus p square, where small r is the radius of the given sphere and small p is the perpendicular distance from the given point to the given plane. Okay, so first of all, already we have here small r is equal to 3. Okay, small r is equal to 3, radius of the given sphere. Okay, and we have to find the p value, where p is equal to, where r is equal to 3 units. Okay, so this is units 3 units, and p is equal to perpendicular distance from 0 comma 0 to what is the given plane? Given plane equation number 2, x minus y plus z is equal to 3. So now we have to find the perpendicular distance. Okay, that perpendicular distance you can see here. So therefore small p is equal to, what is the formula? X minus y plus z minus 3 by under root of x coefficient 1 square plus y coefficient minus 1 whole square plus z coefficient 1 square. Okay, so this is the formula where what is x, y, z? X, y, z is equal to point center of the sphere. Now substitute the values. P is equal to, in place of x, y, z, substitute 0, 0, 0. So 0 minus 0 plus 0 minus 3 by under root of 1 square plus minus 1 whole square plus 1 square means this is 3. Okay, root 3. So therefore p is equal to, we can write mod minus 3 by root 3. That means 3 by root 3. 3 by root 3. Therefore we can write p is equal to root 3. P is equal to root 3. So therefore this is the distance, the perpendicular distance. So therefore we can write this is also units. Perpendicular distance small p is equal to root 3 units. Now substitute p is equal to root 3 and small r is equal to 3 in capital R. Therefore radius of the circle capital R is equal to under root of formula r square minus p square. So therefore we can write that capital R is equal to under root of r square value means 3 square minus p means root 3 whole square. So therefore capital R is equal to 3 square means 9 minus 3 root 3, square root will get cancelled here. So therefore capital R is equal to 9 minus 3 means root 6 units. This is the radius of the given circle, that means guiding curve. So now from this value, keep this value as it is. Now we have to derive equation of the axis of the right circular cylinder. What is the axis of the right circular cylinder? Here you can see the dotted line. Okay, that dotted line is called axis of the right circular cylinder. That axis is passing through 0, 0, 0. Okay, axis is passing through 0, 0, 0 and perpendicular to given plane. That axis of the right circular cylinder passing through 0, 0, 0 and perpendicular to given plane. So take this point as any point x1, y1, z1. Okay, or alpha, beta, gamma. Okay, so and this is from this given plane we can write the direction ratios. Okay, so therefore now I am going to derive the equation of the axis of the right circular cylinder. So now equation of the axis of the right circular cylinder, let first of all take, so 0 of 0, 0, 0 is equal to, so we can take 0 of alpha, beta, gamma. Why? Because that axis is passing through 0, 0 and from equation number 2, what is equation number 2? X minus y plus z is equal to 3. What are the direction ratios? Okay, so direction ratios are, we can write L, M, N is equal to, from this equation 1 comma minus 1 comma 1. These are the direction ratios. And similarly, direction cosines. Immediately you have to find the direction cosines also. How can we find direction cosines? So direction cosines equal to, what is the general formula? Small l by under root of l square plus m square plus n square. Okay, comma small m by under root of l square plus m square plus n square. Okay, so comma small n by under root of l square plus m square plus n square. This is the formula for the direction cosines. Now by using those values we can write l value 1 by under root of, again for these three values if you apply the square then we will get root 3. Directly I am writing. Okay, so m value minus 1, again root 3, n value 1, again root 3. These are the direction cosines of the given plane, direction ratios of the given plane. Now with the help of them, okay, so axis of the right circular cylinder, passing through origin O 0, 0, 0 and perpendicular to given plane. What is a given plane? So x minus y plus z is equal to 3. So this equation, axis of the right circular cone is also a generator. So therefore equation of the generator, otherwise we can call it as equation of the axis, is we can write so you know very well, x minus alpha by small l is equal to y minus beta by small m is equal to z minus gamma by small m. This is the equation of the generator or equation of the axis. Why? Because axis is also one of the generator of the right circular cylinder. Now in place of alpha, beta, gamma substitute 0, 0, 0. In place of l, m, n substitute these values. From that condition we will get the axis of the right circular cylinder. So now axis of the right circular cylinder, x minus 0 by 1 is equal to y minus 0 by minus 1 is equal to z minus 0 by 1. So therefore x by 1 is equal to y by minus 1 is equal to z by 1. Okay, finally we got the equation of the axis of the right circular cylinder. Now from that axis, what is the help of to derive this equation? By using this equation we can find the perpendicular distance from this point to center of the sphere. Okay, so now equation, now directly I am writing projection value. Okay, so projection of so you can take this point before going to take the projection. See here. So yeah, now here I am indicating one more point from the origin. If you take like this, okay, so this is the projection of, if you take any point p of x1 comma y1 comma z1, p of x1 comma y1 comma z1 be any point on the given right circular cylinder. Okay, projection of OP on axis of the right circular cylinder is OM. Okay, projection of OP on the axis is OM. Now we are going to deriving OM equation. Clearly you can observe OPM is a right angle triangle. So you know very well, after getting the right angle triangle equation, already we have this value and we have this value root 6 and we have this value. So now we have to derive OM value. To derive the OM value, now what I am saying, so before going to derive the OM value, first of all let P be any point. First of all let P of x1 comma y1 comma z1 be any point on the right circular cylinder, So if you take that point, so now projection of OP on axis is OM. Okay, projection of OP on axis is OM. So now therefore OM is equal to what is the projection equation? L into x minus alpha plus m into y minus beta plus n into z minus gamma by what is that value? Under root of L square plus m square plus n square. Okay, so now substitute all the values. Here x, y, z means point on the right circular cylinder. So in place of x, y, z, I am substituting that point x1, y1, z1. So therefore, what is the L value? L value 1, x1 minus 0 plus m value minus 1, m value minus 1, y value y1 minus 0 plus n value 1, z1 minus 0 all divided by under root of 1 square plus minus 1 whole square plus 1 square. So the next step I am writing directly. So therefore projection OM is equal to x1 minus y1 plus z1 by root 3. x1 plus x1 minus y1 plus z1 by root 3. Okay, this is the projection value. So take it as equation number 1. Okay, already 1 అయిపోయింది, 2 అయిపోయింది. So this is equation number 3 and now take it as equation number 4. From diagram, so you know very well triangle OPM is a right angle triangle. So therefore now I am writing equation. Therefore from triangle OPM we can write it is a right angle triangle. From triangle OPM, so it is a right angle triangle. We can write OP whole square. OP whole square is equal to OM square opposite side plus adjacent side MP square. Okay, so are you getting my point, ma? OP is hypotenuse. So what is OP? Distance between from origin to P. So distance between from origin to P means we can write in this format. Okay, so that means x1 minus 0 means x1 square plus y1 minus 0 means y1 square plus z1 square is equal to OM. Just now we got that value. What is the OM? x1 minus y1 plus z1 by root 3. This is the OM whole square plus MP. What is the MP value? Root 6 radius of the circle. Okay, I will show you. This is the OM value, x1 minus y1 plus z1 by root 3. And so previously you have that MP value. MP is nothing but root 6. This is the MP value. This is the root 6 units MP value. So now after substituting all the values, see, now take this LH, this value to LHS. So therefore x1 square plus y1 square plus z1 square. Okay, so therefore minus we can write separate the square value x1 square minus y1 square plus z1 square whole square by root 3 whole square means you will get the value 3 equal to root 6 whole square means 6 only. So therefore now so expand this value x1 square plus y1 square plus z1 square minus 1 by 3 I am writing outside. 1 by 3 I am writing outside. So therefore a plus b plus c whole square formula. Okay, what is a plus b plus c whole square formula? A plus b plus c whole square is equal to a square plus b square plus c square plus 2ab plus 2bc plus 2ca. According to this formula, expand that given condition. So therefore, if you expand that thing, so in place of a here we have, sorry, this one x1 gada. These are not x1 squares, x1 y1. Okay, so writing mistake. So now x1, a square means x1 square, x1 square, b square means minus y1 whole square means y1 square plus c square, z1 square, a square plus b square plus c square plus 2ab. Plus 2ab means plus 2 into x1 into b means minus y1 plus 2bc minus y1 into z1 plus 2ca, 2 into c value z1, okay, into a value x1. Okay, with this that expansion completed, it is equal to RHS value 6. Just I am writing again x1 square plus y1 square plus z1 square minus 1 by 3 I am writing as it is. So x1 square plus y1 square plus z1 square. I am multiplying this minus 1 by 3 with this value and multiply this minus 1 by 3 remaining 3 values. Okay, so minus 1 by 3 also I am multiplying. See here, plus into minus minus, plus into minus minus, plus into plus plus. So from these 3 values, from remaining 3 values, okay, so I am taking minus common. If you take minus common, so minus into minus. Okay, if you take minus common, so 2x1 y1 minus 2x1 y1, I am taking minus common. Here also minus 2y1 z1, I am taking minus common, 2y1 z1. Here plus 2x1 z1, here you will get to 2z1 x1. Okay, so equal to 6. Now from these two values, okay, from this value and this value, I am taking x1 square plus y1 square plus z1 square common. Okay, if you take that value, so I am taking x1 square plus y1 square plus z1 square. I am taking this value common from the first two values. So in place of this value, 1 will be there, ma. Okay, so 1 minus from second value minus 1 by 3. 1 by 3. Okay, so minus into minus plus, take 2 also common. If you take 2 common, 2 by 3 into, we can write x1 y1 plus y1 z1 minus z1 x1. So this is equal to 6. Okay, so therefore minus into minus plus, from the remaining 3 values I am taking 2 also, then it will become 2 by 3. So now simplify this value. If you simplify this value, x1 square plus y1 square plus z1 square, 1 minus 1 by 3, take the LCM, 3 minus, okay, 3 minus 1 by 3, so that implies you will get again 2 by 3 only. Okay, if you simplify that value, I am writing in the next slide. So continuation, ma, x1 square y1 square plus z1 square, that LCM value I am writing first. So 2 by 3, LCM value 2 by 3, and x1 square plus y1 square plus z1 square plus second value 2 by 3 again, x1 y1 plus x2 y1 z1 minus z1 x1 equal to 6. Now take a LCM. Otherwise you can take 2 by 3 common, you can send that value to RHS. Okay, so therefore take 2 by 3 common overall ga. So if you take 2 by 3 overall common, x1 square plus y1 square plus z1 square, simply x1 y1 plus y1 z1 minus z1 x1 equal to 6. Send this value to RHS. So 2 by 3 if you send to RHS, it will become 3 by 2. So therefore x1 square plus y1 square plus z1 square plus x1 y1 plus y1 z1 minus z1 x1 is equal to 6 into 3 by 2. 6 into 3 by 2 means 2 ones are 2 3s are 3 3s are 9. So take therefore the required, so now I am writing therefore the required right circular cylinder, required right circular cylinder equation is, required right circular cylinder equation is, I am writing final equation. So remove, actually this is the locus of the point, you know very well, p of x1 comma y1 comma z1, this point locus is only this equation. Okay, whenever you are writing the final equation, in place of x1 y1 z1, write xyz, that represents the locus of the all points in this format. So therefore final equation x square plus y square plus z square plus xy plus yz minus zx, take 3 3s are 9 kada, so take that value to LHS, minus 9 is equal to 0. This is the required right circular cylinder equation. Okay, so in this format we have to find the equation of the right circular cylinder by using the given guiding curve. Okay, so this is the total explanation of this problem. I hope you understand this problem very well. In the next lecture we are coming with one more problem. Okay, based on this method we have few more questions in CA publication, LMR and CA publication material. Okay, just to go through once again all the problems based on in this method. Okay,